You write the specs for all 5 of them saying, okay, this is the issue, this is what needs to be fixed, da. And then in parallel, all those issues are being drafted or documented as to how you're going to go about actually solving this stuff, right? So let's say, hi everyone, my name is Jay. I'm a software developer. I've been working as a software developer for the past 5 years now. Today's topic that I wanted to discuss is the evolution of software development over the past couple of years. In my short experience as a developer, I've seen recently the birth of AI, but what I've also learned working with more senior individuals is that people have actually lived through several evolutions or transitions of how the software development process worked. So from what I've seen and also from conversations with senior individuals in the companies, that early on, way back whenever they started, like in the early 2000s, things were way more different for them at the time, when they were just writing code for maybe for CDs or that you'd install on a CD or a floppy disk at the time. Whereas now, most things, most applications we access through the internet, through the SaaS model, and there have been many changes throughout the years, and in all these scenarios or cases, there have always been fears of what this will replace this and this will replace that. That's another thing that we're experiencing now with AI and what it might replace, whether it will take away jobs for developers and things like that. But what I wanted to share is how software development kind of changed throughout the years, and how maybe this is also another crucial stage in the evolution of programming. So in the mid 2000s, I hear people talking about how cloud computing, or mid 2000s to the late 2010s, around there, where people would say, people tell me that cloud computing at the time started the way you had AWS offering cloud computing services, where now companies could take their on-prem solutions and then run them in the cloud. Now, most recently, we've got AI, and how for the past 5 years that has changed software development completely, with things like spec-driven development, where instead of having to write the code, you essentially instruct your AI model or your AI agents to do the coding for you. So I think we're at a stage, or we're still at the stage where, as a developer, even throughout the past years, you've always had to remain humble, keep learning, because there's always something new to learn. And now we've got AI, and who knows what comes next after this, and what evolution lies ahead for us as developers. I think now maybe if you're starting out in your career, that's one thing to leverage AI in your development process and see how that can benefit you in your career. Obviously, fundamentals, I still think those are important. Still, learn the fundamentals of whatever it is you're coding in, whether it's C#, JavaScript, Python, and all things like that. The coding principles and paradigms are still fundamental to know. And so I think let's keep learning and see what lies ahead. Whatever new processes that evolve, the things have happened in the past before, and it's a matter of adapting and making sure the new processes that exist also benefit you or align with your way of work.
Can you share the tips on how you go about your spec development?
Yeah, so on the spec-driven development, how things work. Though I attended an Amazon workshop, and what was highlighted at the event is that there's companies that maybe for their applications and systems they barely write any piece of code. What they'll do, maybe like with the agent, or an AI model like Opus or any other cloud model, you essentially link your code base to the AI model, and you define you explain what the repos are about, or what the problem is that you're trying to solve, and instead of asking you to implement a fix in one prompt, what you do is first you document or write a spec, or you ask the model to write a spec and say, I need a spec for this. This is the issue, this is what you're trying to solve. That's vastly different from early on when we started using these AI models to actually code, where you just instructed to like fix this code. It doesn't do this, it does that, blah, blah, blah. So instead, you first document what the issue is, and then document what the solution or the steps to solving the issue is before actually asking the model to write any code changes. And then you instruct it to document what test cases are going to change. And essentially what this does, it's the same process as you would have done when you would manually review your code and manually highlight where things need to change, what code needs to be introduced or modified. This will then list out all the steps, and then you review the spec to say, okay, I see this, this is noted, but I forgot, or it forgot to maybe highlight this, and that. And then in that way, you have like a documentation of actually what issues are you solving, or what are the issues are actually being solved by the model, instead of just having it run a fix for you without a proper analysis of what the issue is that you're trying to address.
So with the spec-driven development, right? What's one thing that would make devs different from one another? What would make a dev stand out? Because it's not like now your fundamentals is like a different thing.
Yeah, and the fundamentals remain the same. What maybe is different is the speed at which you can ship issues. So let's say you have 5 issues or Jira tickets that you need to solve for the week. You can use a tool like, let's say, Superset, right? Where you can run all these 5, and also a colleague of mine introduced me to all these tools, and I also have learned from him. So it's something that's also new to me, and I'm still learning a lot of this stuff. And essentially what you do, you'd have these 5 tasks that you have for the week, run them in parallel in a single day or in a short amount of time, where you write the specs for all 5 of them, saying, okay, this is the issue, this is what needs to be fixed, and then in parallel, all those issues are being drafted or documented as to how you're going to go about actually solving this stuff, right? So let's say you have an issue on maybe billing, you have an issue on whatever it is. Those will all run in parallel. They'll document, the agents will document the fixes for you. And then when one is done documenting, you review the first documentation to see if it actually is fixing or if it's missing anything in the process. And then once all of them are done, you ask them to implement the changes or the fixes, if you're okay with them, of course, in parallel as well. And obviously this will run in work trees, so each separate branches and stuff like that. So you can have all these issues sorted out in parallel without you actually touching any bit of code. What you can do instead after that is review the fixes, test them out, although it will still write automated tests for you, but you can still review your own work or the agent's work to see if it actually works in the way it is intended to, as long as the context is there and the documentation is there. So whatever is documented is what the agent will actually implement. So that's all I have to share today. I hope this helps someone out there, and I hope you guys find it useful. Thank you.